This video is an introduction to differentiation, and it's about the power rule. So the power rule is of the form d by dx, which is the derivative of this function a to the n, is your original exponent will be taken to the front as your coefficient, that number multiplying your function, and then your original function a to the n, you'll now subtract 1 from your original exponent. Okay, so this is the form of it. Let's see what this thing actually means. Alright, so this first example, it says the derivative of 7x to the 5. I can rewrite this thing as 7x to the 5. Okay, now I'm going to differentiate what is inside the parentheses here. So this would equal to my 7 times, if I bring my exponent to the front here, it would be 5. So it's 7 times 5, x raised to my original exponent, which is 5, and then I subtract 1 from that. Okay, so this would give me 7 times 5, that is 35, x raised to the 5 minus 1, that is 4. So my final answer is 35x to the 4. So this is my answer for this question here. Alright, the second question is, we should find the derivative of x to the 9. So again, I'm going to take my exponent to the front there. Alright, so if I take my exponent to the front, I will have 9 there, times x to my original exponent, which is 9, and I subtract 1 from that. So this would give me 9 times x, that is 9x, and 9 minus 1, that is 8. So my final answer is 9x to the 8. Okay? Alright. Now let's look at these down here. It's the derivative of 5. 5 is a number that's a constant. Whenever you differentiate a constant, your answer will always be 0. So if I differentiate 5, that is just 0. Okay? And the derivative of pi, remember pi is a number. Pi is 22/7 or 3.142, and it continues. Alright? So that's a number. So if I differentiate a number, that is just 0. Alright? If I differentiate e is a number that is 2 point something. Okay? So when I differentiate that number, that is still 0. Okay? Alright. Let's continue. Now, if I take the derivative of x, remember that when you don't see an exponent, the exponent is 1. So I put my exponent there. Then I take the exponent to the front. Okay, so if I take this one to the front, this would equal to 1 times x to my original exponent, which is 1, and I subtract 1 from that. Okay, 1 times x is just x. So this would give me x to 1 minus 1, that is 0. But remember that anything raised to the 0, that is 1. So my final answer here is just 1. Okay? Now if we look at this one here, again, the exponent here would be 1, because we don't see an exponent. Alright? So if I take this to the front, this would give me 7, which is this, times my 1x raised to the exponent, which is 1, and I subtract 1 from that as well. Okay? 7 times 1 is 7, so that would be 7x, 1 minus 1, that is 0. But remember that x to the 0, that is 1. So my final thing here is 7 times 1, which is just 7. Okay? Alright. Let's look at how we differentiate fractional expressions. Okay? Let's look at how we differentiate fractional expressions. So, the first move is to take this expression to the top. And if we take it to the top, the exponent will now become negative. Okay? So this will equal to x to the negative 3. Alright? Then we take the exponent to the front. So this would give me negative 3. That's my exponent. So that's my coefficient now. That's negative 3 times x to my original exponent, which is negative 3. And I subtract 1 from that. So this would give me negative 3 x raised to the negative 3, negative 1. That is negative 4. Okay? Now, but usually we don't leave our answer with a negative exponent. So if your exponent is negative, it belongs in the denominator. Okay? So your final answer would be negative 3 divided by x now to the positive 4. And this would be your final answer here. Alright? Now let's look at this one here. Now, I can rewrite this thing as 4 1 over x squared. Alright? And again, I take my x squared up here. And if I take it up, my exponent is going to become negative. Okay? So this would be 4 times x to the negative 2. I could put this thing here. Okay? Now I bring my exponent to the front. So this would give me 4 times, my exponent is negative 2. Bring it to the front, that would be times negative 2. X to my original exponent, which is negative 2. And I subtract 1 from that. So this would give me 4 times negative 2, that is negative 8. That's negative 8. X to the negative 2, negative 1, that is negative 3. Again, because our exponent is negative, it belongs in the denominator. So your final answer would be negative 8 divided by x cubed. Okay? When it goes in the denominator, it becomes positive. That would be your final answer there. Alright? Now, let's look at how we differentiate radical expressions. So, if I have d by dx of the square root of x. Now remember that the square root of x technically means that there's a 2 as your exponent there. Okay? And you don't see an exponent for the x, so the exponent for the x is 1. So your index here is 2, and the exponent for the x is 1. So I can rewrite this thing as x raised to the 1/2. So the square root of x is always x to the 1/2. Okay? Now I have my x to the 1/2. I can take my exponent to the front and then subtract 1 from my original exponent. So if I take my exponent to the front, it will be 1/2, which is my exponent, times x raised to my original exponent, which is 1/2, and I subtract 1 from that. Now if I take 1, if I say 1/2 minus 1, that is negative 1/2. So this would give me 1/2 x raised to the negative 1/2. Okay? And remember that if your exponent is negative, it belongs in the denominator. Okay? So this part would give you 1 over 2. This is my 1/2. X now to the positive 1/2. And then I can rewrite this part here in the radical form. Remember that x to the 1/2 is the same as the square root of x. So this would just give me 1 over 2, the square root of x. And this would be your final answer here. Okay? Let's look at another one. What if I have the derivative of, let's call this thing 5 over the third root of x squared. Let's say that is what we have. Now, I can rewrite this thing as 5 times 1 over the cube root of x squared. And remember that this thing can also be written as 5 times 1 over x squared raised to the 1/3, because this is telling us that it's the third root. Okay? And I can simplify my fraction here as 5 times 1 over x to the 2/3. Now I bring my exponent up. Okay? So if I bring my exponent up, that is going to give me 5 times x to the negative 2/3. Alright? In this case, I bring my exponent to the front. So that would give me 5 times negative 2/3 times x now to my original exponent, which is negative 2/3, and I minus 1 from that. Alright? So let's continue it. Let's continue it here. Okay. Remember that when you use a whole to multiply a fraction, you're using the whole to multiply only the numerator part of it. So it would be 5 times negative 2, which is negative 10 over 3. So that would be negative 10/3 x to the negative 2/3, and I can express this negative 1 as negative 3/3 because I want it in terms of this denominator. So negative 2/3 minus 3/3, that is negative 5/3. So this would be negative 5/3. Okay, but because it is negative, it means that this part belongs in the denominator. It belongs in the denominator. So I can write this thing as negative 10 over 3. This is my negative 10 thirds. And now x to the positive 5 thirds. Okay, but I'm going to express this thing in a radical form. The radical form means the denominator here is telling me which root. So it will be the third root. So I can rewrite this thing as negative 10 over 3, the third root of x to the 5. Okay, and this would be your final answer there. Hope the product rule or the power rule, I hope the power rule is a little bit clearer to you. Okay, more videos will be coming out with some other laws of differentiation. Have a fantastic day.